Thank you very much. I trust you can see my screen all right. I assume someone will stop me if you can't. So I'm sharing the screen that I'm sharing. Okay,
Yep.
great. Okay, so good afternoon, everybody.
Sorry, we're still waiting the
screen's not being shared.
Yep.
Hang on. Let me.
Yeah, maybe you can reshare.
I need to share it again. That's all right.
Yep, all good now.
Can you see that now?
Yep.
Okay, thank you.
Thank you.
Okay, let me just minimize this panel. Okay, so good afternoon, everybody. So let me introduce myself. I am Kathleen Hansmann, speaking to you from Bristol in the United Kingdom. I'm the Global Product Manager, Geology, and this means that I look after Datamine's flagship geological packages, Studio RM, and the recently introduced Studio RM Pro. Geology is a key function for any mine or exploration venture. Mining activities cannot take place without geologists and the detailed work that we carry out. We are responsible for identifying and quantifying a mineral occurrence from exploration through to grade control. We do this through systematic data collection and storage, and we use this data to build accurate surface models of the geology. In these models, we do statistics and we build numerical predictions of the occurrences of metals of economic interest. So in simple terms, we sort out and model geological data to make predictions about the amount and the whereabouts. The activities a geologist does are possible because of technology. Of course, we could do these without them, like you might imagine a mine 50 years ago, but you would find that your geology department would have considerably more staff and considerably less output. These days, the marginal grades from mines are lower and the types of deposits that are mineable are on average a lot more complex. We follow best practice and comply with the mineral codes so that our predictions are as close as possible to the truth. Technology is advancing rapidly. 20 years ago, it took a highly skilled resource geologist to produce an ordinary kriged estimate which extended into weeks of analyses. The same now can be created and validated in an afternoon. 10 years ago, the only way to create geological domains was through tirelessly linking sections, and you really had one shot at your model. And now that technology has come a long way. It was very difficult to update a model if you obtain new data. Now you're able to produce automatic wireframes and spend more time trying out different scenarios of your model. Varograms used to scare geologists. Well, they might still. And varograms were only understood by a select few. Now they're a non-issue. Planning drill holes used to be done with a drawing compass and Excel spreadsheets. Now this is all automated. Conditional simulation was just a pipe dream, and it took incredibly long time to run. Now these models can be used in practice to add new dimensions to quantify the risk of your work. So, Datamine are leading the way in technology advances. We have created the most comprehensive set of tools for resource geologists to produce robust models and provide reliable answers. Technology is constantly advancing, and we have a team of software engineers who build new tools and maintain our products. We have ongoing dialogues with our consultants and our customers who share their pain points and their ideas, which help us develop tools that advance the industry. Okay, so enough about the introductions. Let's get into the software. So these are the topics that I will cover in today's presentation. I will start with a discussion about Drillhole Planning. This conversation goes into detail about the features we developed and recently extended in Studio RM and Studio EM. Then I will talk about creating geological models. This is quite involved, and I'll talk about it from several aspects and cover a range of new implicit modeling tools available in Studio RM. Following this, I'll talk about Studio RM Pro, which is a new product from Datamine that includes Studio RM, Advanced Estimation, and Supervisor in one product. It's the ultimate tool for geostatisticians and for resource geologists. So thank you for your attention, and let us get into it. Deciding where you are going to drill a hole is a complicated task. Drilling is extremely expensive, and holes often need to be very long to add value to your resources and to the operation. Your mine probably wants to spend as little as possible on drilling to achieve the most information, else it's not a cost-effective exercise. It's easy to miscalculate where a drill hole will end up, as the drill path deviates through layers of rocks of different competencies, and the path can go all over the place. And a hole that misses its target is a very expensive mistake, and it's an expensive mistake that happens a lot more frequently than we'd like to admit. So Datamine's Drillhole Planner, or DH Planner as we've grown accustomed to calling it, was designed to solve these types of problems. It's designed for both underground and surface drilling and is equally useful for exploration and for production activities. For surface drilling, not strictly limited to open pit mining, as you may drill a surface hole for exploration or for reaching an ore body that is to be mined from underground, you can easily lay patterns of holes, move individual holes, and see where these holes will end up. This type of drilling, where you get to lay out a neat grid and when firming up a resource, is entirely possible. But let's face it, this is not your typical use case unless you are working on a brownfields exploration where you're drilling a new ore body from scratch. Frequently, there is existing drilling, and the drill hole planning is an exercise where you need to place holes relative to the locations of other holes. In these circumstances, you are able to see new drill holes relative to your existing drilling and model your existing drill holes and models and adjust these drill holes as required. You plan a hole to land on or pierce through a surface by a set amount. When you pierce through an ore body for resource definition, you're interested in the target position. Having a regular grid on surface is sometimes not feasible, and given complex terrains and on-surface activities. What matters is achieving a regular grid so your sampling has equal support at the point of the ore body. You're also unable to drill from anywhere. For example, there might be a slope or a man-made structure or a big hole in the ground that makes setting up a drill rig at a particular site impossible. So Drillhole Planner allows you to pick the target point and find holes that are feasible from the available locations. You can dynamically see what the path of the hole is and how it's made up from the azimuth dip and the deviations like lift and drift, and determine if that particular hole is possible to drill from there and the parameters are within the threshold. When drilling, the drill hole path often traverses complex layers of rock. So these have different competencies. And it's not just one uniform rock that you're drilling through. With the changes in rock type, the drill bit responds differently, causing unexpected deviations in the hole. So having flexible drift and lift down the hole allows these complexities in the geology to be modeled, and you can more accurately predict and monitor how the drill hole will penetrate through the earth. It also allows for drilling of fans, which was shown at the start of the video. You can easily generate a set of points on surface that represent targets and extend these from a starting point. This is perfect for underground drilling, where you need to design a complex pattern to penetrate a vein or ore body. It's difficult to obtain correct azimuths and dips for each hole and limit these within the capabilities of the available drill rig. So you can easily do this with Drillhole Planner. This tool allows you to refine and complete your drill hole planning. Existing holes can be edited, modified, and you can rename these and ultimately export the final holes to your database, or have the files exported with the key information so the drillers are ready to get to work. So in the video I've shown here, I've demonstrated a few of these features. As with all our products, the development is ongoing, and these are features that we're currently working on and have not yet been publicly released. They will be released in the upcoming version before the end of the year. Okay, so just back to the table of contents. Next up, we'll be talking about our automatic modeling and going through our contact surfaces, our veins, and lastly, our categorical and grade shell modeling. So, as a geologist, you need to build a model defined by whatever data you have available to you. The most common is drill holes. However, it's often guided by other data sources as well, like point data, mapping data, channel samples, geophysics, old maps, existing models, and our own interpretation. The model you produce is only as good as the data that inputs into it, and it needs to dynamically change as your understanding improves and there's more data available. In this part of the presentation, I will take you through a new tool that we've developed for modeling geological contact surfaces. These are the boundary surface between geological units. This tool was released recently, about a month ago, in Studio RM 1.10. So the workflow for creating models is to build hard surfaces or wireframes that delineate zones of interest from the zones that we find less interesting. So zones with grade and zones without grade. These might be solid bounding shapes or open surfaces. These surfaces are then woven together to create a block model, which is what ultimately controls the volume in your model, and it's used for the basis of your grade estimation. So let's focus here on surface modeling. I'm rushing through these slides as there's a video showing how this tool works. So building these models used to be an onerous task where we needed to link strings and points together to define these wireframes. It was very manual, and a time-consuming process. Now we have the tools to do this automatically with a ton of user controls, especially in areas of limited data, so as to guide the software to build a model that is geologically accurate and exactly the model that you're looking for. In the most recent version of RM, we released a brand new command for modeling geological contacts from drill holes, which is useful for erosional depositional contacts in the simplest form. Now you'll see a lot of these techniques, these could have been done using the older tools, modifying your DTMs or doing this very manually. But what we've done is we've taken these tools and we've made it easier, and we've made it an interface that's designed exactly for geologists to work with the type of data that geologists use. It also creates this module also creates surfaces from points. So you don't need to have drill holes at all. You can just use a points file and actually model those into a surface. You can also create a quick topography from your collars, because very often, particularly for consultants, you're given a deposit and you're asked to do something and you might be missing some data. So you can now generate that data that was missing, or maybe survey haven't created a survey of your most recent pit, so you could use your grade control data to quickly create a topography for the new area. You can also model contacts from complex geological packages where the geological units, where there are multiple units that are cross-cut by dikes, veins, or intrusions in the same particular mineral code. And you can use that with this ignore column. You're also able to model contacts at any orientation, where you have complete control of the best fit plane. Individual contact points can be turned on and off, and manual contact points can be added with the click of a button. There's smart end of hole support, which allows contact points to snap to, pass below, pass above the end of hole points. The boundaries of the surfaces can be automatically defined with a custom string, or you can assume a boundary which you've used, or you can model these to a proto model. Of a modeled fault. The command was designed for geologists, and it was ready to use with this first version that was released. The command is highly interactive and is able to deal with a range of types of geological deposits, and is specifically built for very difficult data because, as you know, it's all very well when you try it with a demo set, but the trick is trying it with your own data, which is a lot more complicated often. So it doesn't expect the data to be perfect prior to processing. They're tools that help you work through difficult modeling situations to build a model that is suitable for you. Because let's face it, geological data is difficult. And software is meant to make our lives easier, not harder. The command uses the minimum curvature method to fit the surface to the points, and this is similar to the method that is what is used by the vein from sample command. We've designed the user interface to have the same look and feel as Datamine's other automatic modeling tools. So it has all the nice to have features that are already in there, like restore support and the ability to script the command. In this video, I've demonstrated the use of the surface command to generate several flat contact surfaces with a more complex vertical surface through the center. This type of modeling has never been easier and more accessible for geologists, and I really hope that you're able to find and get use out of this tool and enjoy using it. Okay, onto the vein modeling. So this command has matured into a very well used and extremely useful command. The command is for creating solid models of veins, dikes, or any closed volume feature with a distinct upper and lower surface or hanging wall and footwall surface. The list of features in this tool are too many to just list at this point in time, but let me cover a few of the most important ones. The tool will generate a vein model from any data without intervention, and it includes new tools to refine the model, as the initial model you create may be a bit naive and you may need to tweak it in certain areas to get it to do exactly what you wanted. You have complete control of the boundaries, from automatically creating these based on your data to allowing the user to draw a new boundary or modify the boundary that was generated by the software and then use that. It's easy to exclude external data, for example, from underground mapping, and do this and use this data as a supplementary data source under the additional points. You can switch on and off hanging wall points, and you can insert new data points to force the context to shift, or you can use a trend to guide the vein, where you don't specify the upper and lower points, but you say, I want the vein to head off in this direction. Contacts are created snapping to the hanging wall and footwall points, and the algorithm fits the data in an extremely plausible way, making high-quality, accurate vein models. You can add in data anywhere, but this is obviously most useful in areas where data is missing, and you can switch on and off troublesome footwall and hanging wall contacts. The level of control is essential when producing a model of this data. The data will automatically, but optionally, pinches out where it makes holes where the vein disappears, where you may have a hole that traverses your vein that has no data. There are ways of realistically controlling the volume. So we're currently adding the functionality to pinch out the veins along the edges as a further optional volume reducing parameter. Where very often when modeling these types of veins, people want to be more conservative with their modeling than the reality, and rather be on the safer side so that the grades are not over predicted in your output model, where you might have the risk of getting higher volumes than you planned. As with all our commands, development and maintenance of these commands is an ongoing process. We have developers working on these right now. The veins that are produced have straight shapes between the contacts, and they create shapes that are acceptable for geological models. We've also developed batch modeling for creating veins for multiple units in a file, and you can change the settings for any vein, and all the settings you use are recalled. Once created, you can combine all of these surfaces to create a block model of your deposit, which is what I'm showing here. So I've recorded this video to demonstrate a bit more than just the vein tool, but the entire process of creating a block model using those surface tools. The best way to determine if this tool is suitable for you is to try it on a standard Studio RM. So if you aren't using it yet, why don't you give it a try, because it's available in the standard software. Okay, so I'm going to speak a bit more about the categorical and grade shell modeling. So categorical and grade shell modeling offer modeling the types of shapes which change significantly over small distances and often have shapes that are difficult to capture with your more traditional types of models. These are, for example, highly disseminated ore bodies, lithologies, complex shapes around grade packets. Very often, these types of shapes do not have a distinctive upper and lower surface and are considered just a single closed surface or multiple single closed surfaces. So categorical modeling was released a while ago, but we've done significant overhauling of the methodology, which has resulted in drastic speed improvements, stability improvements, and more favorable results. Benchmarking of the runtimes shows significant improvements of up to 20 times faster than what we were seeing in previous versions. Categorical modeling can be used to model extremely complex geological shapes, where precise surface modeling is unsuitable and manual wireframing just takes too long. So we've done a lot of verification of these commands against client data sets, and we're seeing very favorable results. We found specifically that there's good volume reproduction when compared against manual modeling, and it's a good fit for complex shapes that would take days and weeks to model manually. For more complex geological packages, the command uses multiple trends. These are the trends here. You see the ellipsoids in the bottom left that mimic the shape and size of continuity and basically tell the algorithm which direction you would like it to go. They guide the surface build to build a valid geological data, a valid model of the geology. These are optional. You can run the command just straight off, in which case the command will determine its own ellipsoids. The idea of ellipsoid trends is to guide the shape of the model with an ellipsoid that defines the expected continuity and shape of the final model should have. In areas where the ore body is skinny and narrow, the ellipsoids can reflect this, and in other areas the trends might be oblate and smaller. And that is so that can kind of capture what it is you're trying to model. So the command is bringing together some complex Gaussian algorithms, and we have some mathematicians who are working on these problems for us. There are further enhancements to this command expected in the upcoming versions of Studio RM, and these commands are still quite new. I didn't include a video of the categorical or grade shell modeling, but I created some comparisons that show how this tool will create different shapes when using the same data with different commands. This vertical structure was created using vein from sample tool and the categorical tool. You can see how the disseminated nature of the vein is better captured with the categorical tool. Looking at these two in section, you see how the pink shape showing the categorical model versus the green shape showing the vein shape actually gets in here and actually captures some of the hollows within the ore body and actually creates this as separate pods, which might be what this drill hole data is actually showing, where the vein command tries very hard to fit a plane to a shape which is otherwise often too curved for an actual vein. I'll go back to the previous slide so you can see a bit more. You can see there how those individual pods are coming through on the left, which is probably for this type of vein, a more desirable shape actually than we're getting from the vein model. Although the vein, it's just that they're two completely different methodologies. So this is giving you an alternate which you might want to consider for modeling some types of ore bodies. It's also pretty good for the grade control type modeling where you want to constrain grade with below a cutoff and using the grade shell tool for that. Okay, so next we will be talking about Studio RM Pro. This is a new product suite from Datamine software where you have the combined power of Studio RM, Supervisor, and Advanced Estimation. It's the most comprehensive geostatistical resource estimation package on offer. So when Supervisor joined the Datamine family, I was extremely excited. When I worked as a mineral resource manager up in Ghana, I used Supervisor with Studio RM, and I found that the two packages were perfectly complementary. In fact, I was unable to do my job without both packages. Supervisor is marvelous. I only have been allocated 45 minutes to speak today, but I assure you that if I were given longer, I would be able to, and I'll be happy to cover a lot more about the functionality in that as well. But you've already had 2 talks from Oscar and just now from Ian on this package, and I'm certain that you're already convinced that supervisor is the way forward. So Datamine have also made strides in that we've made grade estimation faster with CoCrig. This process uses new programming techniques that have made the process multi-threaded. So this means that the calculations happen in parallel and you can compute the results at much faster speeds than you have before. So CoCrig is part of Studio RM's advanced estimation, and you only have access to this faster grade estimation with this module. When you're running different scenarios and testing the impact of parameter changes on your model, speed is the most important thing. If you have to wait 45 minutes to see the impact of a change of parameter, it'll take you weeks to produce a model that you're looking for. And you may have run out of time to check everything and make sure that the model's of the highest standard that you want. If that 45 minutes is reduced down to 4.5 minutes, it means that you can work more quickly and you can really work as quickly as you think. A resource geologist immediately becomes more efficient at their job, and they're able to turn around models faster with more time for validation and their work, so you'll see less mistakes. So it's really a no-brainer. All resource geologists agree that resource geologists need this. We need faster estimation. Okay, so sorry, I'm getting a bit sidetracked. Let's backtrack. So what is Studio RM Pro? This is a combined solution where a license includes Studio RM, which has everything you know and love, and all of the CAD processing, block modeling, implicit modeling, plotting, reporting, estimation. Advanced estimation, which has the faster grade estimation, soft boundaries, outlier management, uniform conditioning, and then supervisor, which has your variograms, simulations, contact analysis. Okay. So Studio RM Pro means that everything you're getting is in one solution from a single vendor. In these packages, you have the ability for your geological modeling and exploratory data analysis and to carry out your variography. You can do your grade estimates using any technique that is suitable for your situation, and this is also extremely fast. This includes your standard linear techniques like inverse power of distance, nearest neighbor, kriging, both ordinary and simple kriging, and advanced techniques like multivariate estimation, uniform conditioning, conditional simulation, multiple indicator kriging. Your estimate is validated completely, and you can trust that, you can therefore trust that it's correct if you've gone through the correct validation steps. Then evaluation and reporting is a straightforward task, and working with your model, seeing visually what is done, thoroughly understanding your model is also easy. So we're keeping supervisor as its own package, of course. And it does not make sense to combine all of this functionality into Studio RM. However, we are embarking on several projects to integrate the functionality between Studio RM and Supervisor, which makes the 2 packages work together more seamlessly. We've analyzed the processes from both packages and discussed with users who have told us they would like to see, and we're focusing on delivering this to the users. So we're aware that there are some tools that exist in both packages. You have a choice to do your variograms using the manual processes or the auto fitting in advanced estimation, or whether you want to carry out your variography in Supervisor. So, and this comes down to user preference and which tools are easier to use. And no one's dictating which tools you should be using if you have working with Studio RM Pro. But on this side, I've listed a comprehensive set of tools that are offered between the 2 packages. And they span right across the geological modeling and advanced resource modeling workflows. So as I said, we're currently improving the flow of data between the packages. So this is made up of several projects which are at different stages of completion. So on the smaller side, we've enabled writing of Datamine files directly from a supervisor and working on improving some of the conventions between the packages. As the packages were initially created by different vendors, they had some different conventions. We need to ensure that they essentially speak in the same language and that converting data is seamless. So we're currently working on the functionality to retrieve parameters created in your supervisor project. So for example, variogram models that are created for different domains and allowing these to be seamlessly imported into advanced estimation directly from your supervisor project. So this makes it easier to use the solution without faffing with files and going to CSV file in between and converting those to Datamine file, which risks introducing errors due to human oversight. Some other projects we're working on at the minute are, some of these should be released soon. So we have some more projects working on CoCrig, specifically allowing for angled estimation and allowing nearest neighbor and inverse power of distance to make use of dynamic anisotropy. And some of the other projects are at the feasibility and planning stage, which means we haven't yet worked out exactly how we're going to do it, but we're in discussions about how we're going to move forward. For example, we're looking at a live link between these products, which would allow for shared selection, which would work well, for example, with the new cluster analyses tools that Supervisor are putting in and allowing for data that you've selected within Supervisor to be visible directly into Studio RM. Okay, so just focusing on some of the tools that are available in RM Pro. So I just want to give a bit more detail about dynamic anisotropy. So this is an industry standard way of working where your search and variogram are adjusted with a structure to estimate better around corners and naturally smear grades in a realistic fashion. Now, this is not new technology. This is technology that's been around for a few years. But what we've sometimes realized are that sometimes people don't always fully understand and grasp these. So it's good to so often show some of the older technology in with the new, just to remind people what's there. So this slide illustrates two different ways of showing the dip and dip direction of the mineralization as interpolated into the block model. The upper section shows an arrow orientated in 3 dimensions. One arrow for each block model one arrow is for each block model cell. The lower section shows a subset of the ellipsoids representing the search ellipse. Only some of the ellipsoids are shown, otherwise it would just be too cluttered. So the lengths of the 2 axes of the ellipsoid are in the plane of the ore body are equal, but the length of the axis perpendicular to the ore body is smaller. From the top section, it can be seen that as well as following the hanging wall and footwalls in the sections, in the center portion, the ore body is dipping towards the viewer. The bottom section shows how the search ellipsoids follow the orientation of the mineralization. So using this technique creates for a better estimate and will improve your estimation reconciliations if it's applied correctly. So advanced estimation also makes use of multi-threaded multivariate estimation. It's a big mouthful of words, so let me unpack that. Multi-threaded refers to the technique where the computer uses different threads and actually runs the calculations in parallel in the background. Whereas multivariate, I'm referring to the fact that here it's showing an iron ore deposit with 6 elements being estimated as a package together. So it's basically a set of grades together, which uses the variance of single grades to improve the estimates of the secondary elements. It does not, so it presumes that some of the data is co-located, which is what it will use to create the covariograms. And then it's assuming that a second variable may have been estimated a lot more. So you may find that in this deposit, iron was estimated throughout, but some of the secondary elements weren't always estimated. So it's sort of the first estimate carries the other estimates. we've also included soft boundary estimation. So soft boundary estimation was always possible with the older techniques, but it was something which it wasn't always that auditable. It was something which you needed to very often use macros and scripts which were non-standard, and actually it was sometimes a bit confusing how you achieved the results that you got through soft estimation, whereas now these have all been parameterized. So let me backtrack onto what soft boundary estimation is. So this is estimation where you can use samples from adjacent domains in the estimation of some domains. So this is commonly applied where you see a gradual domain boundary, where there isn't a sharp decline in grades at the boundary. So perhaps there was an intrusion where fluids spilled out over into the adjacent domains, and you find that there was grade smearing from the high-grade intrusion into the units next to it, but as you travel further away from those units, the grade drops off. So it's simple to use, and what you do is you select which sample domains then affect which model domains, and you configure that through an additional estimation parameter file or your ZPAR file. So looking at outlier management. So outliers are samples that fall outside of your expected range of values. They occur naturally, and especially in highly log normal type deposits like gold, they can cause quite a problem. So they're fine and they're acceptable, but these do wreak havoc on your estimates, and especially if they're not managed correctly. So there are numerous ways that these can be managed, and the choice is yours about how you want to. The choice comes down to the type of deposit you have, and we're really not being prescriptive about what is best practice. But what we wanted to offer was the tools to do it in the way which you see fit, and which is best practice, and which is most suitable to the type of data that you have. So the new outlier management allows you to restrict the impact of these samples by a distance. So if an extremely high-grade sample occurred, you might want the adjacent samples to remove that high grade and not be completely removed like it is through capping. So for example, you might say, well, if I get a very high grade value, I want blocks that are within 10 meters to see that high grade value uncapped. But I want data further away to mask that value, as I don't want an extremely high grade value occurring in one place to smear grade into all of the adjacent blocks. So a block outside that distance would only see the capped value, or you could exclude it entirely. So it's also very easy to configure and to run, and it can so you can see, because of the speed of the process, you can actually see very quickly how this affects your results. Okay, so we can all make use of technology to help us in our everyday work and to make our work become easier. So Studio RM is improving rapidly, and Studio RM Pro is growing from strength to strength. So with your feedback and support, we'll continue to improve the products and we'll work towards making your work easier. So Studio RM is just such a big product. It's extremely extensive, and it's been it's been going for over almost 40 years. It's Datamine's biggest product. So giving an overview is very hard. So I just chose a few key topics to talk about. But obviously your questions may extend a bit more into some other parts of the package, which I haven't necessarily shown here, which is fine. So I want to thank you all for listening, and I hope that you enjoyed my presentation.